Hello all, welcome. In this video we'll look at how to make a spinal implant components. Last video series we looked at how the dental implants are made. As you can see on the screen, I have 4 components pulled in for one of the common spinal implant systems. The common spinal implant system we are looking at today will be going to be a pedicle screw and rod system. So pedicle screw and rod system, most of the manufacturers they use the titanium as the raw material. So other more complex devices of the spinal system will be using a PEEK. So that's a polyether ketone. All the material specs you can go and look in the websites for different spinal implant manufacturers. With respect to the pedicle screw, the titanium, as long as the titanium is meeting the implant grade, which is a titanium 6 aluminum 4 vanadium ELI titanium metal. The titanium metal is made by the different medical approved implant grade steel manufacturer. So they will be made from out of a titanium sponge. They get the titanium sponge from the mine. They will get it across the globe because that's one of the commodity, very expensive commodity. So whoever is the cheapest commodity manufacturer will supply the titanium sponge. Once it comes to the mill, the titanium sponge will be mixed with the different alloying elements such as molybdenum, vanadium, aluminum, palladium at right weight and percentages to make up the strength of the metal with respect to the tensile strength, the corrosive properties, microstructure properties as per the spec. But as long as you can get it from the manufacturer that can meet that titanium 6 aluminum 4 vanadium ELI, then you are all set to make a spinal implants. So all the material, the chemical composition, the chemical properties and mechanical properties are meeting the standards of the ASTM or wherever the country you are looking at, the ISO standards. So there'll be that's a must to be used for spinal implants, because these are the medical components used for the crucial part of the body to fix the body, to fix the spine. As you all know, spine is one of the most important organ of the body. So that's should be a zero compromise on any of the parameters that you use to make up these implant systems. It's highly critical that you understand every single feature, how to design it, how to make it in terms of either CNC turning or CNC milling, EDM, other manufacturing process out there to make up these components. So we will, in my videos, I like to keep it short and sweet, 6 to 7 minute videos. I've been covering the videos like how to design a screw, how to make a taper screw, how to make a double lead threads. So all these elements are adding up to how to making a multi-lead screw system. If you have more questions, you can direct message me. I can help you out in what are the important aspects, attributes in designing these implant systems. So we'll, as you can see on the screen, we can pull out those components that will make up one of the common systems of the spinal implants. So once you know that the titanium that you are getting is made from the electric vacuum melt or electro slag remelt, it's highly critical that these are based on the vacuum melting furnace, because the steel mill need to control the oxygen and the nitrogen within that furnace, so that they don't want those oxygen furnace to screw up the melt of the melting grade. So the mill will continuously monitor the chemical composition. So once it's done as per the international standards, after the post processing will guarantee that different hot rolling and cold working and annealing will guarantee the material properties. As for in this video, we will follow up with the tool path and program how the spinal implants are cut in an efficient way. So what the right material is bought to make these spinal components that will meet the yield, tensile, elongation specs. Then the next thing that you need to talk about is how to apply the different tool path to make up the make these implants. So one of the critical feature of all these implants on the pedicle screw, as you can see, those are the thread system, right? So I did cover about a thread system in my old videos, but I can give you a gist of the concept of what this system you're looking at. So the thread system needs to resist all the axial load that acts upon the implant. So all the pull-out forces that will be acted on the human body as it recovers from the after the surgery, we need to resist all the pull-out forces. So these buttress threads are designed such that the load and the clearance flank are instead of having a V 60-degree inclusive thread angle, this will have a 45 on one side and about 2 to 5 degrees on the other side. Sometimes some of the manufacturers will prefer to keep it 0, but when they keep it 0 on the top side, then it's tough to come up with a cutting tool that will go and cut that side of the flank without any clearance for the chips to evacuate. So it's highly critical that the chip control is done really right to make these implants right in manufacturing without compromising on the tool life. So the system you're looking at here will have a pedicle screw, will have a spinal hook and a rod system. Then it will have a set screw that will come in, and once the rods are put in through here, the set screw will come and lock it. Now let's look at how these implants are manufactured.